First up, we have Dror Berel.
Thank you. Can you hear me? Yeah. The title of my talk is How Tidy Everything, how I finally got to dive in data structures and analysis of tree, graph network, time series, thanks to their tidy packages. I'm a statistical consultant. These are some of the places I studied, worked, teach, including some hospitals, industry, and recently consulting in pharmaceutical companies. The outline of the talk is review R packages for data structures and functionalities for trees, graph networks, and time series. It is not going to be a tutorial. It's just going to be my own opinionated review. What is tidy? Well, that's many here already know, so no need to go in details. It's an ecosystem of packages in R that allow you to do really cool stuff. But to me, I would loosely define it as preserving principles that I was taught on day one in my statistical training, that variables should be in columns, observations are in rows, and the values are at the intersection of each row and column. But basically, what we see on our IDE or in the console is looked like a matrix or a data frame or a tibble, but behind the scenes, there is a whole object with engineering that make us work with much easier and conveniently without worrying about what's happening behind the scene of that nice table formatted. So my stories began back in the day, I think 2008. I did my master thesis on nucleotides in tRNA, and I created this CAR classification and regression tree model with nucleotides and visualize it as this tree. I did it with rpart, that was the main package then, and I wanted to color and move those labels at the edges, and believe it or not, I did it in PowerPoint because that was the tool I was familiar with then. And then I kind of like left off this tree object. But keep in mind, things have not always been tidy, right? So over the years, I keep seeing packages about graphs, trees, all kind of like cool stuff with a tidy and GG suffix and prefix. And I was a little bit overwhelmed because for me, I know those, I have those regular traditional non-tidy packages. So if I have to do it again, which package should I choose? I was overwhelmed. So today I'm going to follow kind of like the journey I went through and review which packages I would recommend today. So again, we have the tabular data format, and we also have nested list. My initial goal was to go back and forth from table to nested list and back and forth to table. But nested list perhaps could be also presented as a tree, as a data structure. So how do I go from a tree to nested list to table? And a tree is also a special case of a graph network, not to confuse with deep learning graphs and neural networks. Just I refer to the abstraction of the data. So my overall goal was how to go back and forth from each of these four data structures in a most seamless way. That's what I'm curious about. If you're still not confused that trees is something you should learn or go deep in, I'll give you some use cases. If you ever use the Plotly package for visualizations of tree maps, sunburst, Sankey, those force you or expect the data format, the input to be in a tree structure. JSON, YAML, XML files, these are deep nested list of list of list of list of list. You got the idea? So this is also could be represented as a tree. Folder, file system, organization structures. Right? I hope you're convinced. Some of you may be convinced just by the algorithmics of this tree. The traversal, pruning, aggregation, going depth first, breadth first. There is a great book by Corman, which is a great motivation. However, I would say if you are new to the field, do not be deterred by that. There is plenty for you to do just with the data structure and the visualization. And later on, if you'd like, you could go and learn that complexity. So here it is. That's my review on a time scale. From the left, back in the day, the packages used to be in stats age class and dendogram object, which are still, you may still see them around. Then at some point in molecular evolution, they developed the ape and the phyllo-based package. And the modern now is an ecosystem called treedataverts, which is a collection of 3 packages, treeio, ggtree, and tidytree, which I'm going to expand next. But I would also mention some specialized packages. Extend datatree, which is an amazing package. Last night, I figured out there is another one called treeplier and treedata.table. And also, so do we have some base people in the audience? Don't be ashamed. There is also good old friend rrapply, which in spite of everything I'm going to say, sometimes I use and it solved the problem in very easy, elegant solution. So let's look at some example. Here I create a tree from the ape package. The function is called r3 and it says 4, so it's going to randomize 4 edges. And then with a tree plot, I simply plot it. Let's look at the structure, right? So I'm going to use the base function called str, which is going to print a list of the embedded attributes. These are with the dollar signs. And I could say there is some edges and tip labels. Yeah, maybe that's good enough. But then what's happened if I convert it into a tidy object? So I'm going to use the function as treedata from the tidytree, and then I'm going to look what's under the hood with the str. And then, yes, it does look familiar. So it's inherited something from the phyllo package. So that's imply of a good design of the previous package because the new modern package decided to adapt it and inherit it. But there are also special attributes, slots, for data and extra info, which are in a tibble format. Right now they're empty, but let's see how we could use them. So then I convert this tree object into a tree data table df and just print it. And that's an amazing input for me, even before I do anything, because it gives me a table with parent, node, branch length labels, something that I could more intuitively understand and play with. Then I create another table independently of the tree, which just have labels and traits for me to map. I map it with this traditional full join from the tidyverts ecosystem, and I present it again as a tree data. Now, if I looked at what's happening underneath, I see what I've seen before, but I also see a new column called trait that was mapped and joined into the original table with a simple join. Finally, all I have to do is plot it with the companion ggtree package. And now I'm almost as close as to what I wanted to do. That's in my initial example. So here I was able to use the trait as an aesthetics for color. So switching gears, trees are also a special case of a graph network. And here are 3 more ways to say it. Graph use cases are shortest path, how you go from A to F in the minimum shortest cost of the edges. Centrality, hub, if you're an air carrier and you want to put a new airport, where should you put it? You could leverage the graph structure. Here's another quick review. Back in the day, there were packages called SNA, StatNet Network, then igraph package, which is also an amazing package. It's also has, I think, almost same API in different languages. And then the modern version of that is the tidygraph with a companion visualization called gggraph. So let's do the same similar example. Here we have a tabular data set with countries, and the countries are within continent, and for each of those countries, we have the population. If we present it as an igraph from the igraph package, we see igraph 2BCD83C. I have no idea what that means. UN, I could guess what it is, 196, 195. Again, not much intuitive. However, when I do it with a tidygraph as table graph, it's much more clear. It tells me 196 nodes, 195 edges. It is unrooted tree, and then for each of the nodes and the edges, I have a designated tibble, which again, I could do joins, I could do whatever I want. So to me, this is something I could see. It's much more visualized, much more intuitive. I could work with that. Tidygraph also come with a tidy workflow, right? Those verbs, join, bind, and the mapping. So no longer for loops. I could do elegant stuff with purrr, apply, map, style recursive, plotting with gggraph, and other functionalities. I am a content contributor, so you could also find it on my Medium blog and find others. So here's the review. So again, use whichever you find. My recommendation is with the modern one, because first of all, it inherits the previous packages. So that's apply. Things was good enough for the developers of the modern package. So they adapted the old one. We did without reinventing the wheel. They just put some other wrappers around it. Switching gears, time series, right? So that's always been confusing to me. I never took a time series class, so I kind of like had to learn it from just the packages. But there are at least 10 plus packages, data structures, ecosystems for time series. I think the classic one is XTS and Zoo, but they were never intuitive to me. And there is a package to master them all called TSBox that gives you some utility functions to go from one to another. And that's here on the right side. What we don't see here is a tidy version of this object. So before we look at the tidy, again, this is the traditional one I think that most people are familiar with. Here we have some sample data with open stocks and high and low and close prices, and here's the date. But when we look at the structure, not much intuitive or explainable to me. I don't know how I could extract the date. It's always been a pain. With the tidyverts, right, not to confuse about the spelling, VERTS, that's a group by Rob Handyman and others. It's a whole new ecosystem, and they introduce an object called tsibble, again, not to confuse it, TSIBBL, and some other packages, independent packages ecosystem, and a companion package called Brolgar, which suggested implementing a tidy solution. So let's look at this tsibble function. The first object is data, just a matrix or a data frame. Then you have two parameters. One of them is the key for the experimental unit. In our case is the example. The other one is index for the time, hour. And then what it does look like a standard tibble, but it also comes with those additional information. It tells you the number of rows, number of columns, the time unit, and the experimental unit here in blue. What's nice about it, and maybe even annoyingly nice, is that the class will nudge you until your input and data parameters meet all the sufficient terms. But once you do that effort and make it into the object strict criteria, you're there, because then plotting and detecting gaps in time units, everything is going to be almost seamless because it's part of the scope of the object. Take-home messages. Tidy tabular format is intuitive, at least to me, and easier to use. Learn by trial and error, object conversion between packages. This is how I learn it without opening those algorithm books. Object and STR is your friend. Package scope and relationship to other package in the ecosystem is nice to understand. Respect the base R. Try multiple packages simultaneously, because one of them might have better documentation and the other one have better examples. Try it yourself with your favorite use case theory and real world problem. Thank you.